Good morning, all of you. Today we discuss about the first year and first semester mathematics. In this first semester mathematics, the 4 units are available. The first unit is algebra part. Okay, in these two parts are divided partial fractions and matrices and also the determinants. Okay, and trigonometry part is there. The trigonometry part also divided in two parts. Okay, the different types of functions are available. Okay, here now the today's class we started about the algebra part, that is a partial fraction. The first topic is partial fractions. We know that fractions, how to find out the fractions we learn about in the lower level. In this lower level we know that fractions and the different types of fractions, different types of fraction like that proper fraction and also the improper fractions. But here the specially we have to learn about here the partial fractions. Okay, now we see the partial fraction introduction. We go to the partial fraction introduction. First we see the objectives. On completion of this period you would able to identify the proper and improper fractions, procedure to resolve the given fraction into partial fractions. Are you clear here? Identify the proper and improper fraction. How can we identify the proper fraction and improper fraction? And also we learn about resolving the fraction into partial fractions. Okay, the partial fractions. You see the partial fraction. Here the first one is unknown to known. Unknown to known. Here what are these? You observe here the fractions are there 1 by 2 comma 1 by 3 comma 1 by 4 comma 3 by 2 comma 4 by 3 comma 5 by 4. Here these are called number fractions. Already we learn about these numbers in the lower level, that is the 6th class or 7th class topic is there. 1 by 2 is there. Here 1 is called numerator and 2 is called denominator. We know that. In which 1 by 2 comma 1 by 3 comma 1 by 4 are proper fractions. Okay, proper fraction. How can you identify the proper fraction here? You observe here in this one the numerator is less than the denominator. Numerator is less than denominator. You observe 1 is less than 2 or 1 is less than 3 and 1 is less than 4. Okay, these are called what? Proper fractions. And 3 by 2 observe 4 by 3 comma 5 by 4. These are called what? Improper fraction. You observe here in the numerator is greater than the denominator. You observe 3 is greater than 2 and also the 4 is greater than 3 and also 5 is greater than 4. These are called what? Improper fractions. Okay. You observe here the numerator is less than the denominator is called proper fraction. Numerator is greater than the denominator is improper fraction. Just you remember that. Here we know that 1 by 6. How to write this one? 1 by 6 is equal 1 by 2 into 3 is also we have to write this type. 2 into 3 is equal to 6. Then write here 1 by 2 minus 1 by 3. 1 by 2 minus 1 by 3. We know that the same way 1 by 12 also sorry, 1 by 12 is equal 1 by 4 into 3. Here also we write 1 by 3 minus 1 by 4. 1 by 3 minus 1 by 4. This is called resolving a number fraction into simple proper fraction. Simple proper fraction. You observe here 1 by 3 minus 1 by 4. When we have to do the LCM part, that is equal to we get 1 by 12. Okay. Here in this period we are going to study how to resolve by taking polynomials in place of numbers. Okay, in place of numbers. Now we discuss the polynomials. We know that the numbers 1 by 6 how to write here 1 by 2 into 3, that is equal 1 by 2 minus 1 by 3, and 1 by 12 is equal 1 by 3 minus 1 by 4. Now we go to the polynomials. You see the polynomial. Already we know that this word is polynomial in the 8th class, 9th class topic is there. Okay, an expression of the form a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on plus an, where n is a positive integer and a0 comma a1 comma a2 so on an are real numbers, is called a polynomial in x. It is of degree n if a0 is not equal to 0. Okay, we see once again an expression of the form. Already we know that in polynomial in 8th class, maybe 8th or 9th is available polynomial. How to write the polynomial equation? A0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on plus an, where n is a positive integer and a0, a1, a2 so on an are real numbers, is called polynomial in x. It is of degree n if a0 is not equal to 0. Okay, now we see the continuous part. A constant is regarded as a polynomial of degree 0. A constant is regarded as a polynomial of degree 0. If a polynomial is equated to 0, it is called an algebraic equation. We know that in algebraic equations, okay, whenever the polynomial is equated to 0, like that ax square plus bx plus c is equal to 0, those are called what? In algebraic equation. Okay, a constant is regarded as a polynomial of degree 0. If a polynomial is equated to 0, it is called an algebraic equation. You see the example, x square plus 2x plus 5 is a polynomial of degree 2. Here highest power is what in the polynomial? 2 is there, so that the polynomial of degree is 2. Okay, x square plus 2x plus 5 is a polynomial of degree 2. Now we go to the rational fraction. Rational fraction. Okay, an expression of the form f of x divided by g of x. An expression of the form f of x divided by g of x, where f of x and g of x are polynomial in x and g of x is not equal to 0, is called a rational fraction. Is called a rational fraction. Are you clear? An expression of the form f of x divided by g of x, where f of x and g of x are polynomial in x and g of x is not equal to 0, is called a rational fraction. You see the example, 5x minus 6 divided by 2 minus x minus x square. 2 minus x minus x square. You observe here 5x minus 6 is f of x, 2 minus x minus x square is g of x. The g of x is always not equal to 0, so that this is called what? Rational fraction. This is called what? Rational fraction. What is the definition of rational fraction? An expression of the form f of x divided by g of x, where f of x and g of x are polynomial in x and also the g of x is not equal to 0, is called rational fraction. A very important definition of the rational fractions. Okay, and also asking the examination point of also one more question, how can we define a rational fractions? Now we see the next one is proper fraction. Proper fraction. If the degree of f of x, if the degree of f of x is less than the degree of g of x, if the degree of f of x is less than the degree of g of x, then the rational fraction f of x divided by g of x is called a proper fraction. A very important definition. This is proper fraction definition is what? If the degree of f of x is less than the degree of the g of x. Okay, the numerator degree is always less than the denominator degree. Then that is called what? Proper fraction. The fraction is called what? Proper fraction. You see the examples. Example number 1, 5x plus 6 divided by 2 minus x square. You observe here the degree of the numerator. Degree of the numerator means the numerator is what? 5x plus 6. Here what is the degree here? 1 is there. The denominator is what? 2 minus x square. Here the degree is what? 2. So that whenever compare the numerator and denominator, the numerator degree is 1 but the denominator degree is 2. So that we observe the numerator degree is less than the denominator degree. So that we have to say that this is called what? Proper fraction. Proper fraction. Whenever the numerator degree, whenever the degree of the f of x is less than the degree of the g of x is called what? Proper fraction. You see the again second example, you observe x square minus 1 divided by x plus 2 into x square minus 1. You observe the numerator degree is 2, the denominator degree is 3. So that this is also called what? Proper fraction. And also you observe number 3 example, 5x square plus 1 divided by x cube minus 1. Here the numerator degree is what? 2. The denominator degree is 3. So that degree of the numerator is less than the degree of the denominator. So that this is called what? Proper fraction. Are you clear? Okay. We learn about fraction and also how can we define the rational fraction, then how can we define the proper fraction. Now we go to the improper fraction. Improper fraction. You observe here, improper fraction means if the degree of f of x is greater than or equal, if the degree of f of x is greater than or equal to the degree of g of x, then the rational fraction f of x divided by g of x is called an improper fraction. Is called an improper fraction. You observe the degree of the f of x greater than and also equal, greater than and also equal to the degree of g of x. Okay. Sorry. You see the examples. Example number 1, x square plus 1 divided by x plus 1. Here the numerator is x square plus 1, denominator is x plus 1. You observe the degree of the numerator is what? 2. The degree of the denominator is 1. So that when you observe the degree of the f of x is greater than the degree of the g of x. So that whenever the degree of the f of x is greater than the degree of the g of x, that is called what? Improper fraction. Improper fraction. Are you clear? Now we go to the second example. X power 4 plus 1 divided by x square into x square plus 1. Okay, you observe clearly here the numerator degree is what? 4. The denominator degree is also equal to 4. The denominator degree also equal to 4. Okay, what is the definition of the improper fraction? The numerator degree is greater than or equal. Greater than or equal. You observe in the second example the numerator degree and the denominator degree. The degree of the f of x and also degree of the g of x both are same, both are equal. So that then this is also called what? Improper fraction. Improper fraction. What is the definition of improper? Degree of f of x is greater than or equal to the degree of g of x. Are you clear? So that we know that how can we define the proper fraction and also how can we define the improper fraction. Okay. Now we see the next one. The sum of two proper fraction is a proper fraction. The sum of two proper fraction is a proper fraction and condition is there. Consider the sum of two proper fraction like that 2 by x plus 4 and 3 by 2x plus 3. 2 by x plus 4 and 3 by 2x plus 3. Then 2 by x plus 4 plus 3 by 2x plus 3, we can do the LCM, we get 7x plus 18 divided by 2x square plus 11x plus 18. Okay, now we observe the degree of the f of x and degree of the g of x. Now what is the degree of the f of x? Only the 1. The degree of the g of x is what? X square. So the degree of the g of x is 2 is there. So whenever you compare the numerator and denominator, the numerator degree is less than the denominator. So that this is called what? Proper fraction. So that what is the condition? The sum of two proper fraction is again a proper fraction. Okay. Now we see the another one. If a proper fraction of the type 7x plus 18 divided by 2x square plus 11x plus 18 is given, okay, then the process of finding the proper fractions, okay, we have to divide it. 2 by x plus 4 and 3 divided by 2x plus 3 is called what? Resolving into a partial fractions. Resolving into a partial fraction. Okay, the before we have to see that the sum of two proper fraction is again another proper fraction. So that whenever the proper fraction is there, we have to split into two fractions, that is called what? Resolving into a partial fraction. Yes, now we go to the topic. Our topic is what? Partial fraction. Okay, partial fraction. Expressing the given rational fraction as the sum of two or more simple proper fractions is called the resolving the given fraction into partial fractions. Okay, how can we define the partial fraction? Expressing the given rational fraction as the sum of two or more simple proper fraction is called the resolving the given fraction into partial fractions. Okay. If an improper rational fraction f of x divided by g of x, f of x divided by g of x, f of x divided by g of x is given for splitting into partial fractions, we first divide f of x with g of x till we obtain a remainder r of x of lower degree than g of x. Okay, if an improper rational fraction f of x of g of x is given, now we have to splitting into a partial fraction. First we divided by f of x with g of x till we obtain remainder r of x of a lower degree than g of x. Now we see, then we express the fraction in the form f of x divided by g of x is equal quotient plus r of x divided by g of x. Then we resolve the final proper fraction into partial fractions. Then we resolving the final proper fraction into partial fraction. Rules to resolve a proper fraction f of x divided by g of x into partial fractions. Okay, here the rules are there. Okay, now we see this one, the four rules are available. Okay, suppose you observe here, whenever given the improper fraction is there, then how to resolve it into a partial fractions? First we have to split into a proper fraction, then after that resolving into a partial fraction. Okay, you have to remember the one note point is there. Whenever the given the improper fraction, we have to split into a proper fraction, then after that resolving into a partial fraction. Suppose whenever given a proper fraction is no problem, directly we have to resolving into a partial fractions. Are you clear? But here the resolving into a proper fraction, the four conditions, four methods are there. Now we see that methods. The first rule, rules to resolve a proper fraction f of x divided by g of x into partial fraction. Okay, now we see to every non-repeated linear factor, to every non-repeated linear factor ax plus b of g of x, there corresponds a partial fraction of the form a by ax plus b, where a is a constant to be determined, where a is constant to be determined. Okay, what is the first condition? To every non-repeated linear factors ax plus b of g of x, there corresponds a partial fraction of the form a by ax plus b, where a is a constant to be determined. We see the example. 3x plus 7 divided by x minus 1 into x minus 2 will have its partial fraction of the form a by x minus 1 plus b by x minus 2. You observe the denominator part. How many factors are there? 2 factors are there. Those are to be non-repeated linear factors. So that how to write in partial fraction format? A by x minus 1 plus b by x minus 2. Now we go to the another one, another method. To every linear factor ax plus b which is repeated r times of the form ax plus b to the power of r as a factor of the denominator, there corresponds r partial fraction of the form, or partial fraction of the form. Okay, we see the a1 by ax plus b plus a2 by ax plus b whole square plus a3 divided by ax plus b whole cube plus so on ar divided by ax plus b to the power of r, where a1 comma a2 comma a3 ar are constants to be determined, constants to be determined. Here example, 1 by x plus 1 whole cube into x minus 3 will have its partial fractions of the form. You observe here in the denominator part, how many factors are there? One repeated factor, another one is non-repeated factors. How many repeated factors are there? 3 is there. So that how to write in the partial fraction format? A by x plus 1 plus b divided by x plus 1 whole square plus c divided by x plus 1 whole cube plus d divided by x minus 3. Okay, here the two methods are completed. You observe the first one is non-repeated linear factor, the second one is repeated and non-repeated linear factors are there. Whenever the non-repeated linear factor is there, directly we have to write a by something and b by something, and again repeated linear factor is there, we have to write a by x plus 1 plus b by x plus 1 whole square plus c divided by x plus 1 whole cube plus d divided by x minus 3. Now we go to the other method. To every non-repeated irreducible quadratic factor, this is the third method. To every non-repeated irreducible quadratic factor which can not be factorized into real linear factors of the form ax square plus bx plus c of g of x, there corresponds r partial fraction of the form. Okay, we see this one, ax plus b divided by ax square plus bx plus c, where a comma b are constant to be determined. Here what? Irreducible quadratic factor. Whenever we have to introduce the quadratic factor is there, then how to write in partial fraction format. Okay, here the example you have to observe, x square divided by x minus 1 whole cube into x square minus x plus 1 will have its partial fraction of the form, a divided by x minus 1 plus b divided by x minus 1 whole square. You observe in the denominator x minus 1 whole cube, that is called what? Repeated linear factor. One repeated linear factor is there, the another one is quadratic factor is there. So that how to write in the partial fraction format? A by x minus 1 plus b divided by x minus 1 whole square plus c divided by x minus 1 whole cube plus dx plus e divided by x square minus x plus 1. This is called what? This is a irreducible quadratic factor. Whenever the quadratic factor is there, then how to write in partial fraction format, that is dx plus e divided by x square minus x plus 1. Here also completed a b c. A by x minus 1 one time, b by x minus 1 whole square 2 times, c by x minus 1 whole cube sorry 3 times, plus 1 quadratic factor is there. Then how to write this one? Dx plus e divided by x square minus x plus 1. Okay. Okay. The next one is what? The fourth method. The fourth method. To every irreducible quadratic factor ax square plus bx plus c which repeated r times of the form ax square plus bx plus c to the power of r as a factor of the denominator. There corresponds r partial fractions of the form. Okay, this is called what? This is repeated quadratic factor. Whenever the repeated quadratic factor is there, then how can we write the partial fraction format? Okay, that is a1x plus b1 divided by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c whole square plus so on, plus arx plus brx divided by ax square plus bx plus c to the power of r, where a1 comma b1 comma a2 comma b2 comma so on ar comma br are constants to be determined. So that we see the example 1 by x minus 2 into x square plus 3 whole square will have its partial fractions. You see this example in the denominator part, x minus 2 is what? Linear factor. That is called also non-repeated linear factor. Here not to be repeated that factor. So that x minus 2 is a non-repeated linear factor. Only one time is there. So that, and again one is x square plus 3 whole square. X square plus 3. This is what? This is a quadratic factor. But here the quadratic factor is repeated. X square plus 3 whole to the power of 2. So that whenever quadratic factor is repeated, then how can you write the format? You observe, one linear factor is there, we write a by x minus 2, that is our plus. Now we write in the quadratic factor x square plus 3 whole square. Sorry, quadratic factor is repeated, so that bx plus c divided by x square plus 3. Okay, one time completed, plus again dx plus e, b c over, next we go to the d, dx plus e divided by x square plus 3 whole square. Okay, clear? Here you observe, one linear factor is there, another one is repeated quadratic factor is there. So that how can we write the partial fraction format? A by x minus 2 plus bx plus c divided by x square plus 3 plus dx plus e divided by x square plus 3 whole square. Okay, here the four methods are completed. You observe here resolving into a partial fraction. How many methods are there? 4 methods are there. Okay, in these 4 methods, the first one is non-repeated, repeated, quadratic and repeated quadratic factor. Okay, now the general method to determine the constants. Express the given fraction into its partial fractions according to the rules mentioned above. Then multiply both sides by the denominator of the given fraction to get and identify which is true for all values of x. Compare the coefficients of like powers of x on both sides of the identity. These are called what? General method to determine the constants. Now you will obtain as many equations as the number of constants to be determined. Okay, you have to observe. Okay, depending on the factors. Okay, now you will obtain as many equations as the number of constants to be determined. Whenever get the equation, we have to equate in the different types of equation and also solve them and find out that constant values. On solving this equation, we shall find the values of the required constant. This is the last point. You observe. On solving these equations, we shall find the values of the required constants. Okay. Now we see the summary. We have discussed about rational fraction, proper and improper fraction, and procedure to resolve the given fraction into partial fractions. Are you clear? What is the summary of today's class? That is what? How can we define the rational fraction? How can we define a proper fraction? How can we define an improper? And also we learn about the procedure to resolve the given fraction into partial fractions. Okay. Now we go to the quiz. Which of the following is a proper fraction? Okay. What is the definition of proper fraction? The degree of the f of x is less than the degree of the g of x. That is the definition. Okay. You observe the a1. A is what? 3x minus 20 divided by x square plus 3x minus 20. And b is x power 4 divided by x square minus 3x plus 20. And c is x square plus 7x plus 3 divided by x square plus 7x plus 10. And the d is x cube minus 5 divided by x square minus 2x. You observe here what is the proper fraction. What is the definition? Degree of the f of x is less than the degree of the g of x. You have to compare the numerator degree and also denominator degree. The second question is what? Which of the following is an improper fraction? Which of the following as a improper fraction? That is 3x minus 20 divided by x square plus 3x minus 20 and 2x minus 1 divided by x square plus 4x plus 3. The C1 is 2x plus 3 divided by 3x square plus 14x minus 5 and D is x power 4 divided by x square minus 3x plus 2. Here you observe the improper fraction. What is the definition of improper fraction? The degree of f of x is greater than or equal to degree of the g of x. Using the definition, you have to find out the which one is the improper fraction and which one is proper fractions. Okay. Okay, in the next class we continue the problems. Okay, thank you very much.